Hello everyone! This project is a tribute to one of our favorite platform games, Spyro the Dragon. Starting from scratch, we recreate in Unity the art and the behavior of the red gems. Let us know what do you think about this video in the comment section below. In Spyro the Dragon, there are different types of gems. To complete the game like a real pro, we have to collect them all. We try to recreate the ruby. First of all, what ingredients do we need for our recipe? For sure, the gem's 3D model, 2 behavior scripts, one to rotate the gem on its position and one to move the gem toward the player. Next, we need a custom shader that show up the brightness of the faces and 2 particle systems, one that follows the gem when it moves and one for the gem's interaction with the player. Let's begin. In Blender, we create the gem's 3D model from a 2D reference. The process is simple. Starting from a cylinder, we reduce the vertices number to 6. We select the bottom face and scale it to 0. We extrude the upper face to create the vertical edge. We extrude again a new face to create the latest part of the gem. With a cutter tool, we hand draw triangles on the upper faces and dissolve the edges that we don't want.
I don't deny there's some strange evolutionary process going on, but mankind won't be destroyed. The fact that you and I are working here today is evidence of that.
Once the model is created, we position the pivot on the bottom of the model. This is required to rotate it correctly. Let's create a new Unity project. We create it from the useful Unity Hub. As version, we use the 2018.3.0 F2. As template, we choose the Lightweight render pipeline, so that we have already included in the project the new Unity shaders and the shader graph. Also, we import the third character controller, so we don't have to script the player's movement. We start from scripting. The movement is composed by a constant rotation when the gem is in idle state, and a jump when the player gets close enough. The idle state consists of 2 kinds of rotations. I can achieve it with a single script. The script exposes a public variable for the rotation speed and one for the axis on which the gem rotates. In the update function, it is called the rotate method of the transform class. Let's prepare the gem. We insert it in an empty parent and rotate it as in the video game. A lateral face is always touching the floor. We assign the script to the parent and set to rotate on y-axis. We assign the script also to the child, but here we set to rotate on negative z-axis. Great! Now the jumping script. It also contains the interaction logic. Inside the onTriggerEnter method, we set through a boolean variable that will start the movement pace in the update function. To simulate the jump, we use the cubic basic curve equation and 4 control points. Once we have implemented the equation in a separate method, we call it in the update method passing the 4 positions and the t parameter. Incrementing the t parameter each cycle, we move the gem from its starting position to the final one, the player position. We add a sphere collider to the gem's parent and we are ready to test it. Perfect! We add another collider smaller than the first one and a rigid body with kinematic set to true and gravity set to false. We return to the script and add a non-collision enter function. Here we destroy the gem because the player has touched it. We are ready for the shading phase. We create a PBR shader and start to add nodes and parameters. Exposed parameters will let us change values easily from the inspector. Starting from the albedo node, we need a color property multiplied for a cube map. The cube map has an important role for the reflection of the rotating gem. We choose a cube map that represents an indoor ambient with white lights. It's not the ideal choice, but it's okay for the moment. To render properly the shader from the camera view, we connect the view dir and normal nodes. To enhance the reflections, we need to work on the emission node. Here we use a Fresnel effect to obtain a white patina. We save the shader and start to play with the parameters until we get a good result. To create particles effects, we need our old friend Photoshop. From a game screenshot, it is possible to study the shape of the effect. There is a circle in the middle that fades to transparency and two perpendicular lines. Once the PNG is exported, we can create particle effects in Unity. We call the first trail particle. This is activated when the player enters the gem's trigger area. The effect follows the gem, so it needs to be placed as child of the gem in the hierarchy. We create a material with the sprite placed in the albedo field. The material replaces the standard material in the rendering section of the particle system. Now it's time to modify the other settings. To use the particle, we add it to the gem script. We activate it in the trigger method and disable it in the collision method. The second particle is activated during the collision and it is similar to the previous one, but it has a different shape and lasts less. To complete the project, we play with post-process effects. Already available with the project's template, we add a post-process layer and a post-process volume to the main camera. We create a post-process profile in the folders and add it to the components field. Adding a bloom effect and color grading the sheen gives a good visual effect. This is the final result. With further improvements we can get really closer to the original gems. What do you think about it? And mostly, do you like the video? Let us know in the comment below and subscribe to the channel. Thanks for watching!